I am Karanam Ajith Rao, Assistant Professor, Vijayanagar College, HOSAPETE. As we all know that an atom consisting of nucleus and electrons are revolving around the nucleus. Nucleus further consisting of protons and neutrons. And it was in the year 1911 Rutherford proposed a model of an atom called as Planetary model of an atom. He has satisfactorily explained the distribution of positive and negative charge in an atom. The alpha particle scattering experiment. It is also called as gold foil experiment, and it was proposed by Rutherford, Geiger and Marsden, and it consisting of a narrow beam of alpha particle emitted from a radioactive substance such as bismuth of atomic number 214 and mass number 83, kept in a lead cavity which is incident on a circular screen coated with zinc sulfide after passing through a thin gold foil of thickness 10 raised to minus 8 meter thickness. Alpha particles scatters in different directions which were observed with the help of a detector. And further, this apparatus consisting of a lead cavity, and at the same time it is consisting of a gold foil which is yellow in color, and red color what you are observing is said to be a detector which is coated with zinc sulfide. Whenever these alpha particles which when being incident on a gold foil, then these alpha particles scatters. And here you are noticing that most of the alpha particles travels through the gold foil remains undeflected, which is represented by the letter A. And some of the alpha particles are deflected through small angles, that is being represented by the letter B. And some of the alpha particles travels back from the foil, and which is being represented by the letter C. So here, why this is happening? So that we can understand like this. Whenever these alpha particles which when incident on a gold foil, then you are observing that whenever these alpha particles which when encounters an electron which remains undeflected. Therefore, as most of these alpha particles remains undeflected, when some of the alpha particles which just encounters a nucleus, then they remains deflected, and they are deflected through small angles. And whenever these alpha particles which when being incident upon the nucleus, there some of them are reflected, some retraces its path along 180 degree. And from this we can conclude the following assumptions: that the number of alpha particles per unit area that reaches the screen at a scattering angle varies as 1 by sine to the power of 4 theta by 2. And we can make the following conclusions. As most of the alpha particle passes through, the gold foil remains undeflected. It indicates that most of the space is empty. The alpha particle being positively charged and having large mass compared to the electron. And a positively charged electron in an atom is positively charged in an atom or concentrated in a small region called a nucleus. The alpha particles travels towards the nucleus directly gets retarded due to Coulomb's repulsive force. The electrons being very light do not affect the alpha particles. Thank you.